Alrighty then, welcome to my video. So here I'm gonna do a problems that involves a unit vector as well as a magnitude or a length of a vector. So now say for instance, you are given your vector. So let's say you are given a u vector, which is equals to 1 to 2 subtract alpha to -2. So let's say you are given this unit vector and the statement says to us, find the value or values of alpha at which number A, at which vector u is a unit vector, and then number B, at which the length of vector u is 3. Okay, so now most definitely we're going to start with question number 1 based on this information provided to us. So we are given a vector, which is vector u, and we are also told for number A that u, it is a unit vector. Therefore, we want to determine the value or the values of our alpha based on this information. So in order for us to solve question number A, this is how we're going to do it. So to solve question number A, they say that vector u, it is a unit vector. So meaning when we talk about a unit vector, its magnitude is equals to +1. And therefore, how do we calculate a magnitude of a vector? So we do the same thing. So now we're going to say the magnitude of our unit vector in this case is going to be equals to root of x squared plus y squared plus z squared. Okay, therefore, after writing this formula, and therefore we're going to substitute our x values, y values, as well as z values. So remember, we are given a vector u. Here we have x, we have y, and we have z. So let me substitute these numbers onto this equation. So our value of x in this case is equals to +1 to the power of 2. And our value of y, it's 2 subtract alpha squared. And then the value of z is going to be -2 to the power of 2. And therefore, as I continue to solve my equation looking for a vector u, therefore 1 to the power of 2 is going to be 1. 2 to the power of 2 is going to be 4. 2 multiplied by alpha multiplied by 2, it's going to be -4 alpha, and then negative alpha to the power of 2, most definitely is going to be positive alpha squared, and therefore -2 to the power of 2, most definitely is going to be +4. And then when I continue with my equation, I'm going to say here I have alpha squared minus 4 alpha, and therefore what is 4 plus 1? Most definitely it's +9. And therefore, we managed to determine the magnitude of alpha of vector u in terms of alpha. But now remember, we were told that vector u, it is a unit vector. So if a vector u, it is a unit vector, we all know that the magnitudes of unit vector is equals to 1. So that means we're going to equate this equation over here with this equation over here. So that means on this side of the equation, I can simply say I have, I have root of alpha squared minus 4 alpha plus 9, which is most definitely is equals to 1 because these two are the same. And therefore, as I continue with my problem, I'm gonna get rid of this root sign by introducing squared on both sides of the equation. Okay, I'm gonna introduce squared over here, also gonna introduce squared over here. Therefore, that means here I'm gonna have alpha squared minus 4 alpha plus 9, which is most definitely equals to 1. If I transpose 1 to the other side of the equation, in fact, yeah, I'm going to transpose 1 to the other side of the equation. I have alpha squared minus 4 alpha. And then when I transpose 1 over here, it's going to be positive 8, which is equals to 0. Now, when I get here, I most definitely have to factorize this in order for me to determine the magnitude of alpha. But the problem is it wouldn't be possible or easy for me to see the factors while this equation is more like this. So that means there are no factors of 8 when I add or subtract them to give me 4. So that means, in that case, what am I going to do? I'm going to use my quadratic equation formula. But I don't prefer using quadratic formula because I find it longer. So I'm going to complete the square of this equation, which is similar as using quadratic formula. So me completing the square, I'm going to say alpha squared minus 4 alpha. And therefore, what is the half of 4? Half of 4, it's 2. And therefore, I'm going to square that half of 4, which is 2. It's going to be positive 4. And therefore, I transpose this 8 on the other side of the equation. It's going to be negative 8. So what I did on this side of the equation, I supposed to do it on the other side of the equation. And therefore, now I'm going to factorize this bracket over here, this 3 times over here. I'm going to open up my brackets. And therefore, here I have alpha factors of alpha squared is alpha and alpha of 4. Most of it is going to be 2 and 2. And therefore, the sign is going to be negative and negative, which is equals to negative 8 plus 4. It's negative 4 most definitely. And therefore, here I have alpha minus 2 to the power of 2, which is equals to negative 4. And therefore, because I'm looking for alpha, I'm going to get rid of this squared by introducing root sign on both sides of the equation. So that means here when I introduce root sign, remember, I'm supposed to insert plus or minus. Now, here I'm going to have alpha minus 2, and then here I'm going to have plus or minus. Remember, what is root of negative 4? We know it's math error, but this is where we're going to introduce the concept of complex numbers. So that means here we have a negative root 1 multiplied by positive root 4, which is the same as this. And therefore, I'm going to say my alpha is going to be equals to, now this is what is happening. I transpose 2 to the other side of the equation, and then here I'm going to have positive 2, and therefore here I'm going to have plus or minus. So now what is the root of 4? It is most definitely positive 2. What is root of negative 1? It's I, which is imaginary. Therefore, my value of alpha for question number A is going to be 2 plus root of 2i. Or another solution, which is its conjugate, alpha is going to be 2 subtract root 2i. And therefore, this is how we determine our numerical values of alpha in a complex form. So that means the value of alpha for question number A, this is the correct solution. And therefore, number B, remember, we were most definitely told that the magnitude of unit vector u, of vector u is equals to 3. So what am I going to do? I go back to where I started. So remember, how do we calculate the magnitude of a vector? This is how we calculate the magnitude of a vector until at this point. So because I've already calculated this, for number B, I'm just going to use this to determine the magnitude of alpha if the length of vector u is equals to 3, no longer a unit vector. So that means this, I'm going to say root of alpha squared minus 4 alpha, I think it's plus 9, yes, plus 9 now is equals to 3. Therefore, I'm going to get rid of this root sign, by introducing squared on both sides of the equation. And then here I'm going to have alpha squared minus 4 alpha plus 9 is equals to 9. And therefore, this 9 cancels with this 9. Now I left with alpha squared minus 4 alpha is equals to 0. Now I have to factorize this. This is simple. I take my alpha as a common factor. Alpha minus 4 is equals to 0. Therefore, here, alpha is equals to 0 or alpha is equals to positive 4. So here we also get two solutions if the length of our vector u is equals to 3. I hope that is making sense.